medicine.
It is.
It was once considered science fiction, but now it's becoming a reality.
It is.
I'm curious to know more about this CRBM.
Okay.
How does it learn to mimic MS progression so accurately?
Well, the researchers used a massive database called MSOAC.
MSOAC.
Yeah, it contains information on thousands of MS patients.
Wow.
Including demographics, relapse history, disability scores,
Okay.
results from functional tests. Think of it as a vast library of real-world MS experiences.
So it's like feeding the CRBM a massive textbook about MS.
Yes, and the CRBM uses all of this information to learn the statistical relationships between all of these different variables.
Okay.
It's like teaching the CRBM to recognize the patterns and connections that underlie MS progression.
And the goal is to create a model
Yeah.
that can generate like synthetic data.
Right.
Or data that doesn't come from real patients.
Yeah.
That looks and behaves just like data from real patients.
Exactly. It's like creating a virtual mirror image
Wow.
of the MS patient population.
But how do they actually teach the CRBM to do that?
Well,
That sounds incredibly complex.
it does involve some complex math and computer science.
Okay.
But the core idea is to train the CRBM to recognize the patterns and relationships in the data.
Okay.
They do this by adjusting the parameters of the model until it produces output that very closely matches the real-world observations.
So they're basically fine-tuning the CRBM
Yes,
until it can accurately simulate how MS progresses in real people.
precisely. And to evaluate how well they did, the researchers used a combination of statistical and clinical metrics. They looked at things like how well the model could reproduce the relationships between different variables,
Okay.
how accurately it could predict relapses, and how well it captured the overall progression of disability.
So what did they find? Was the CRBM able to accurately simulate MS?
The results were remarkable. The paper shows that the CRBM performed incredibly well across all of these metrics.
Wow.
The digital twins were practically indistinguishable from real patients
Really?
in terms of how their MS progressed.
That's really impressive. How did they test this idea of the digital twins being indistinguishable from real patients?
They actually tried to train a separate AI to distinguish between real patients and digital twins.
Oh, wow.
It was like a digital Turing test, and the AI completely failed.
Really?
Its performance was no better than random chance.
So they couldn't tell the difference.
They couldn't tell the difference. That's pretty convincing evidence that these digital twins are the real deal.
Okay, so what else did the researchers discover about these digital twins?
Well, they wanted to see if the digital twins could accurately simulate an individual's disease trajectory.
No.
They focused on how well the model could reproduce changes in a patient's EDSS score, which is a measure of disability in people with MS over time.
So could they actually predict how someone's MS might progress over time?
It was surprisingly accurate. The digital twins were able to capture the nuances of individual disease courses much better than any previous models.
Okay, so this all sounds incredibly promising.
It does.
But are we getting ahead of ourselves? Is this really the future of MS care?
It certainly has the potential to be.
Okay.
But it's important to remember that this is still early stage research.
Right.
There's a lot more work to be done
Okay.
before these digital twins become widely available.
So what kind of work still needs to be done?
Well, for one thing, they need to test the model on even larger and more diverse groups of patients to make sure that it works well for everyone.
Oh.
And they also need to develop user-friendly interfaces that doctors and patients can actually use in a real-world setting. It can't just be lines of code on a screen.
So we need to make sure it's practical and accessible
Yeah.
for everyone, not just computer scientists.
Exactly. Now, before we get too focused on the technical side of things,
Right.
let's circle back to that information about cannabis and MS.
Yeah, I'm very curious to hear more about that.
Okay.
You mentioned that some studies suggest it might have beneficial effects.
Yeah.
Can you tell us more about that?
I can. Well, it's important to note that a lot of the research on cannabis and MS has focused on cannabis-based medications
Okay,
rather than just smoking cannabis.
that makes sense. Using a medication
Right,
gives
okay.
you more control over the dosage,
Yeah.
the specific compounds you're getting.
Right.
Are these medications effective at treating MS symptoms?
There's growing evidence suggesting that they can help manage symptoms like spasticity and pain.
Okay,
For example, Sativex, a mouth spray containing both THC and CBD, has been approved for medical use in several countries.
that's great, but we still need more research to be sure, right?
Absolutely. We need more large-scale studies that track patients over a longer period of time
Yeah,
to fully understand how well these medications work
right.
and whether they're safe in the long term.
And I imagine doing this research is complicated
It is.
by the fact that cannabis is still illegal in many places.
Yes, the legal status of cannabis is a major obstacle to conducting research.
Yeah.
It makes it difficult to run standardized studies across different countries and regions.
It's kind of ironic that we're talking about the potential medical benefits
It is.
of something that's still illegal in many parts of the world.
Yeah,
Hopefully, as more countries legalize cannabis, it'll become easier to study.
I agree. Let's shift gears back to the digital twin research for a moment.
Okay.
Remember how we talked about the CRBM learning from that huge database of MS patients?
Yes.
One of the things that makes it so powerful is its ability to deal with missing data.
Correct. Because not every patient will have the same tests done.
Right.
Or be able to make it to every appointment.
Exactly. In a traditional statistical model, missing data can be a big problem.
Yeah.
It can skew the results and make it difficult to draw reliable conclusions.
The CRBM can kind of work around that.
Yes, the CRBM is designed in a way that allows it to handle missing data while still maintaining the statistical relationships between the variables. Think of it like filling in the blanks in a story
Okay,
while still understanding the overall plot.
gotcha. So this makes the CRBM even more powerful, especially when we're dealing with complex medical data.
It does.
It isn't always complete.
It allows researchers to get the most out of the available data, even if there are gaps. And this brings us back to the concept of statistical indistinguishability,
Okay.
which means that even other AIs can't tell the difference between the real patients and the digital twins.
Why is that so important?
Well, it's not just a cool trick.
Yeah.
It actually tells us a lot about how reliable and valid the model is. If the digital twins are statistically indistinguishable from real patients, then we can be more confident that the model is accurately capturing the real dynamics of MS progression.
So we can trust that it's not just randomly generating data.
Right.
It's actually based on real patterns in relationships.
Exactly.
Okay, I'm convinced these digital twins are pretty amazing.
They are.
But how would someone actually USE their digital twin?
That's a great question.
Yeah.
And it's something that researchers are still actively exploring.
Okay.
But here are a few possibilities.
Okay, I'm all ears.
Imagine you've just been diagnosed with MS.
Okay.
Your doctor could use your digital twin to simulate how your disease might progress over time based on your individual characteristics and medical history.
So it'd be like a personalized forecast for your MS.
Exactly.
Yeah.
This could help you and your doctor make more informed decisions about treatment options,
Okay.
since some treatments are more effective at certain stages of the disease.
Taking some of the guesswork out of the equation.
Great.
I like it.
What else?
What's-
Another possibility is using digital twins in clinical trials.
Okay.
Drug companies could test the effectiveness of new drugs on digital twins before moving on to expensive and time-consuming trials with real patients.
So kind of like a virtual test run.
Yes, this could potentially speed up the process of getting new treatments to people who need them.
Wow. Okay, I'm starting to see how this technology could be a real game changer.
It could be.
Are there any other ways that digital twins could be used?
Well, we could also use them to help people make personalized lifestyle changes.
Okay.
Your digital twin could help identify lifestyle factors like diet and exercise that might be impacting your MS,
Okay.
and then simulate the effects of different changes.
So it's like having a personalized health coach powered by AI.
You got it.
This all sounds futuristic, but incredibly exciting.
It is.
It feels like we're on the verge of a major transformation in how we approach healthcare.
I think you're right. Digital twins have the potential to revolutionize how we treat many diseases, not just MS. But it's important to remember that there are also ethical considerations.
Right. Of course, we talked about those briefly before.
We did.
But they definitely deserve a deeper dive.
They do.
Developing powerful new technology comes with responsibility, and digital twins are no exception.
Right.
So what are some of the key ethical concerns we need to be thinking about?
Data privacy is a big one.
Okay.
These digital twins are built using sensitive personal health information.
Right.
We need to make sure that this information is handled responsibly and that there are strong safeguards in place to prevent data breaches or unauthorized access.
Of course, we don't want people's personal health information falling into the wrong hands.
No, we don't. What other concerns are there?
Okay. What else?
Another important consideration is informed consent.
Okay.
Patients need to fully understand how their data is being used to create these digital twins
Right.
and what the potential implications are. They need to be able to make an informed decision about whether or not they want to participate.
So transparency is crucial. Anything else?
We also need to be aware of the potential for bias in the models.
Okay.
The data sets used to train these digital twins need to be diverse and representative of the entire population. If they're not, then the digital twins might not be accurate or effective for everyone.
That's a really good point.
Yeah.
We need to be careful not to create a system that only benefits certain groups of people.
Exactly. And this is why it's so important to have these conversations now while the technology is still being developed.
Yeah.
We need to make sure that it's used ethically and in a way that benefits everyone. Now, I want to point out one more interesting aspect of the digital twin research.
Okay.
The paper you shared goes into detail about how they validated the accuracy of their model
Okay.
using a variety of statistical techniques.
Tell me more.
Well, they wanted to be absolutely sure that the digital twins they created were statistically indistinguishable from real patients.
Right.
One of the methods they used is called p-value analysis.
Okay. I vaguely remember p-values from statistics class.
Can you refresh my memory?
A p-value essentially tells you how likely it is that you would observe a particular result by pure chance if there was no real effect.
So in the case of the digital twins,
Yeah.
it tells us how likely it is that we would see the observed differences
Yes.
between real patients and digital twins
Yeah.
if the model wasn't actually accurate.
Exactly. And when the researchers compared the digital twins to real patients,
Okay.
they found that the p-values were within acceptable ranges.
Okay.
This means that the differences between the two groups were likely due to random chance, not because the model was inaccurate.
So the digital twins passed the p-value test.
They did. This gives us even more confidence that the CRBM is a robust and reliable way to simulate how MS progresses.
Okay, I'm really starting to feel like I understand these digital twins.
You're doing great. This seems like a good point to take a break
Okay.
and let everything sink in for a bit.
Yeah.
We've covered a lot of ground today.
We have, but there's one more crucial question we need to address.
What does all of this mean for you, the listener?
Right.
How might this research actually impact your life?
That's the question we'll explore when we return.
Welcome back to our deep dive into the world of digital twins and MS. You know, we've explored the science behind these digital models,
We have.
but now I want to bring it back to you,